Is writing a letter considered work? Explain why or why not.
Yes, because it depends on meaning.
Yes. Writing a letter is work because you're using a force to move your pencil a distance. Just thinking about a letter, is that work? No. How do you calculate work? This is something you need to remember for this unit. No, that's your units. How do you calculate it? Force times distance. If either your force or your distance is equal to 0, if you do a multiplication problem where any of the factors is 0, what is your answer? 0. So if the force is 0 or the distance you move it is 0, then the amount of work you do is 0. Okay, Brendan, calling someone new.
Machines change the way forces apply. A simple machine is a device that makes work easier. Machines number 2. Machines change 2 things.
Before I put that up there, where did you find this answer? Emily?
On page 146.
146. Go there now.
At the top of the page. Second paragraph end.
Not really a paragraph. What do you see?
There's bullet points.
2 bullet points. Machines change 2 things. You know, if you're looking for 2 things, usually the book gives you something to indicate there are 2 of them. So, Gavin, how are the 2 ways, or what are the 2 ways that machines work?
Change the amount and distance of force, or change the direction.
I'm moving on. There you go. Yes?
Is changes the size of force needed, is that correct?
Size, but there's something that goes along with size. Size is what I mean by amount.
Okay, so should I just write that?
Size and what goes with the size?
Distance?
Distance. If you change the size of the force, the amount of force, then you have to change the distance that you apply the force. You have to go further if you apply less force, or if you apply more force, you can go less distance. Those 2 go together. The other thing a machine can change is the direction of your force. While you're looking at those pictures at the bottom, what types of things do they change? What do gears change? Do they change size and distance, or do they change direction?
Distance or direction?
They change direction. How about a pulley like you see on this crane? Do they change size and distance, or do they change direction?
Like points. Or
Size and distance or direction?
size and distance.
And
direction.
And direction. Pulleys, especially when, if you look closely at the picture, you can see that there's more than one. When you add multiple pulleys together to make a pulley system, then you can change all of it. Change size and distance and direction. Do you know what I mean by changing direction? When you pull down, the object goes up. How about a compound machine like a tractor? What does that change?
Size and distance.
And? Yep. Something like a tractor or compound machine can change all of them. Okay, calling someone new.
Changing size and distance.
Number 3.
Look at the 2 main ramps. Which ramp
Requires?
requires
So look at these two ramps. I have the ramp in the front shows you it's only 5 meters long. The ramp in the back shows you it's 10 meters long. If you can see the two, maybe Emmett, since you're up front, if you can see those two individuals rolling up the ramp, which one looks like they're applying more force?
The one on the 5 meter ramp.
The one on the 5 meter ramp. This person is applying a lot more force than this person in the back. Why?
Because there's a bigger incline.
Good, it has a bigger incline. It's steeper. Is it harder to go up a steeper hill? Yes, but a steeper hill will be shorter than a less steep hill. Right? Yeah. If the hill is steeper, it will also be shorter. Okay, let's continue reading. Whoever's turn it was.
Machines can apply less force over a greater distance. Machines can apply greater force over less shorter distance.
And you may call on someone new.
Input force F, then I,
Mm-hmm.
Fi, force applied by to machine. Output force Fo, force applied by a machine to object.
So whenever you use a simple machine, there are three things that are working together. What are the three things working together when you use a simple machine? What are the three parts involved in the system? Who applies a force to the machine? You, the person, applies a force to some sort of machine, like a pulley or a lever or a wedge or a screw. And what's the third part? Kara? No, on the lever, the fulcrum is actually part of the machine. What do you use a machine for? Emily?
To make work easier.
To make, what does that mean? Gabe?
Like an object.
Right. You've got to have some sort of object that you're trying to move. You know, I use a pulley to lift the window blinds. There's me, the pulley, and the blinds. You use a shovel to dig a hole. So there's you, the shovel, and the dirt. You use a ramp to move a box. So there's you, the ramp, and the box. You've got to have something to move. Otherwise, there's no point in using the machine. So the input force is done by you. The output force is done by the machine.
I have a question. You know, like if a ramp, like it's an inclined plane. So, what's the like if you were skateboarding or something? What's the object that you're moving?
In that case, you are the input force and the object you're moving.
Oh, okay.
So you can use the machine to move yourself. Right?
Oh, yeah.
Okay, let's continue. Whose turn to read now? Go ahead.
Changing direction from before. Label the input and output force on the pulley shown. Use arrows and words.
So my pulley is flipped from yours. Don't give me left or right. Describe where the input force would be and where the output force would be.
The input force would be at the road.
On which side? The side you pull on or the side with the box?
The side you pull on.
Right. The input force. In what direction would that be going?
Down.
Right. You would pull the rope down. Where's the output force?
The output force is in between the ropes.
What do you mean?
The pulley wheel and the rope.
Which side? It's not between the pulley wheel and the rope. Gabe?
It's the left side.
Right. It's where it's attached to the object. And what direction would the output go? Gabe?
Up.
Right. the pulley changes the direction of force. You pull down, the object goes up. Some of you probably did this part of the question. Some of you probably ignored the second part of the question. What is the other part of this question? Emmett.
How does the pulley change the input force?
If there's more pulley than one, like if there's two.
Okay, how does this pulley change the input force?
Oh, the weight. Or if there's more things, more effort.
Time out. Go back to number 2. There are 2 ways to change the force. How does this pulley change the force?
Oh, less distance. I don't know.
It changes the amount and distance of force or change the direction.
Which one? It only does one of those.
The, the box.
Changes the direction. In this case, the pulley only changes the direction. It does not change the amount of force you need. Let me show you how. Call in someone new.
Keaton.
3 forces, 2 types of work. Input work. Work on the machine. Input force
It equals
equals input force x the distance
times.
times the distance through which the force acts input distance. Output work. Done by a machine. Equals output force times the distance through which the resistance moves. Output distance.
Okay, so we have 2 forces, input force and output force. Those 2 forces do 2 different types of work, input work and output work. This becomes important when you start to calculate mechanical advantage. When you calculate mechanical advantage, you have to know what the input work is versus what the output work is. All right, let's continue. Derek, your turn.
Mechanical ability. Number 5. Mechanical advantage equals output force divided by input force. The number of times the machine multiplies the input force. Has noises. Each machine has their own formula to calculate.
So a pulley is different from calculating the mechanical advantage of a lever, which is different from calculating the mechanical advantage of a, throw that out please, of an inclined plane. Each type of machine has their own formula for calculating mechanical advantage. But the general idea, the general formula, is output force divided by input force. Call in someone new. Mechanical advantage. So here's the difference between the 2. What involves no friction? No one can hear you. Read that again. Divided by. Which one do you think we will calculate? Will we be calculating ideal mechanical advantage or actual mechanical advantage? Sabrina, what do you think? We will actually be doing ideal mechanical advantage. It's a lot easier to calculate if you ignore friction. Then you don't have to worry about adding that factor into whatever formula you're using. All right, Matt, call in someone new.
Mechanical advantage equal to 1. Output force equals input force. Change the direction of the applied force.
For example, a teeter-totter. A teeter-totter does not change how much force you apply. It only changes the direction of your force. What other example did we go over today that is like that? Where I put the same amount of force in to the machine. The pulley on my window blind. I applied the same amount of force as the pulley did, so the mechanical advantage is 1. Okay? The other type of mechanical advantage, the other way you can calculate, Gabe?
Mechanical advantage less than 1. An increase in distance an object is moved to the same force.
For example, a rake, which is a type of lever. In this case, you apply more distance with the same amount of force. It takes the same amount of force to push leaves across your yard with a rake as without it, but you can push it for a further distance. Any questions? Okay, Gabe, calling someone new.
Work transfers energy number 6. Draw a picture of a machine that increases an object's gravitational potential.
Okay, as I walked around yesterday, here's the issue I saw. What does gravitational potential energy mean?
Gravitational potential energy means to lift it.
Right. If you are increasing the object's gravitational potential energy, you have to lift the object. So, what types of simple machines lift objects? Pulleys. Give me another one. Inclined planes, and one more.
Wait, does it have to be a simple machine?
Yes.
Oh.
A lever. Those are the only 3 simple machines that are used to actually lift objects. Wheel and axle, not used to increase gravitational potential energy. Wedge, screw. Actually, a screw could be. You could use a screw if you're talking about like Archimedes screw. You could use a screw to increase the gravitational potential energy of something like grain or water. I didn't put that on there, but. So make sure your picture has a machine, an object, and you are increasing the gravitational potential energy of that object. Your machine should be a simple machine, one of these 3. See how it says number 6? We're on number 6. What you waiting for? And that machine should be increasing the gravitational potential energy of an object. Should be lifting an object. Megan.
Question, could a wedge be an inclined plane?
A wedge is two inclined planes put together, back to back, to make it sharp on both edges.
Okay.
Okay?
Should be drawing of like an actual object.
Yep. All right, let's move on. While you're finishing your drawings, we're going to continue. Crystal, you get to read.
Work transfers energy, which two ramps require the same amount of work.
So on your paper, the ramps are labeled A, B, and C. How are the ramps different, Dawson?
By their 5 meters and 10 meters.
What is that called? What is that measurement of?
Length,
Nope.
distance.
Maybe?
Yeah, distance. Longitude? I can't think of it.
When you measure up and down, you're measuring the height. So C is a taller height, correct? A and B are both the same height, correct?
Yes.
Now, Dawson, you're right that the length of each ramp is also different. But if you are lifting an object to the same height, does the amount of work you're doing change?
Yeah. On like the two smaller.
Think about it this way. If I had a box on the floor and I lifted it up to the counter, right? I used a certain amount of force and I lifted it straight up and put it on the counter. I would have to use a lot of force, right? Now, if I used an inclined plane to do the same job, but my inclined plane ran all the way to the other side of the room and I just, whoop, pushed the box up, I used a way less force, but I had to go way more distance, right? So did I do the same amount of work? Force times distance, remember? Big force times little distance, or big distance times little force.
Yeah.
So I did the same amount of work. So which two ramps require the same amount of work, Landon? A and B. Why does C require more work? Because it's taller. That's exactly right. A and B do the same amount of work because they're the same height. C requires more work because it's taller. Megan.
Oh, there's two questions? Okay.
There are two questions. Bless you. Okay, who hasn't read yet? Kara. Your turn.
Can you get more out than out can never be greater than input?
Why do you think that is? Think about what output and input mean. Who does the input? You or the machine? Wyatt? Who does the input? You. You are the input. Who does the output? The machine. Why can the machine's amount of work never be greater than yours? Right. And the machine applies a force to the object you're moving. Right? So why does yours always have to be a little bit more? No, not exactly. When I use the pulley over there to raise the window blind, why do I have to do a little more work than the pulley actually does?
To make it move? Like just
No? Let's read. Kara, go ahead.
Efficiency can never be greater than 100%.
efficiency.
Is a percentage comparison of work output to work output.
Efficiency equals.
Oh, okay. Efficiency equals output work divided by input work times 100.
So that means it's a percentage. 90% efficient, 70% efficient, 20% efficient. Some work is always needed to overcome friction. Right? If you put a machine between you and the object you're moving, there is going to be friction between you and the machine and between the machine and the object. So some of the work you do, some of the force you apply, has to be for the purpose of overcoming that friction. Okay? Whoops, Kara calling someone new.
Compound machines. A compound
Combination.
combination of two or more simple machines cannot get more work out of a compound machine than you put in.
So these are some compound machines. Would there be more or less friction when you use those compared to a simple machine? More. There's more moving parts, right? There's more places where things are rubbing against each other, therefore more friction. So when you use a compound machine, you actually have to do more work. You have to apply more force than using a simple machine. However, you can still get the job done in less time when you use a compound machine. Very good. Any major questions?